Okay, good evening, everybody. Let's start today's discussion. Today, we will focus on the assignment 2 solving. Hope you have gone through the assignment. So, today we will discuss whatever the problem you have faced, whatever difficulty you have want to discuss in this meeting. Okay, am I audible? Okay, let's start. So, can you see my screen? Okay. Okay, so let's start today's discussion. So, uh, today our first question is the Newman projection of the below. There is a projection formula is given, and there is four options. So, which one is correct? You think? Please interact with me. Okay, otherwise it is very boring session. So, tell me which one you think is the correct option of the question one. What is the correct form? It is a staggered or gauge or eclipsed or most stable conformation of 2-methyl-butane. Anybody? Hello?
Staggered.
Sorry?
Staggered form.
Yes, it is a staggered form. So, so there is two type of conformation we can write. Which form is this?
Staggered form.
Yes. And this one?
Eclipse.
Eclipsed. Yes. So other options are not true, and this is the staggered form of 2-methyl propane, right? So any
Yes, sir.
doubt, anybody? Instead of writing in the chat box, you can also respond. Means that will be better. Otherwise, every time I have to open the chat box to see. Okay, if possible, you can respond in the meeting. Okay, coming to the next question. Okay, how many stereoisomers are possible for the following molecules drawn? Tell me, how many
Four.
stereoisomers? Sorry,
Four.
how? How can you determine?
Sir, there is two asymmetric center.
Yes, two asymmetric center. This one and this one, right? So there is two asymmetric center in the molecule. So if we put in the formula 2 to the power n, number of the stereoisomer, that is 2 to the power 2, that is 4 stereoisomers are there, possible stereoisomer, right?
Yes, sir.
Okay. Anybody has any doubt?
No, sir.
Okay. So this one, which of the following molecule will not show optical activity? So how can you determine which molecule doesn't show optical activity?
Sir, option C.
Yes, option C. Why? Option C has,
Because, sir, this is a meso compound.
yes, this, and the which element of symmetry it has?
There is a sigma.
Stereochemistry I.
Yes, there is a I.
Yes, sir.
So as we know that if that molecule has any kind of sigma plane or any kind of point of symmetry, then that molecule is what? Optically inactive. It doesn't has any kind of optical activity, right? So this what kind of center of symmetry it has? It has center of symmetry. The element of symmetry is center of symmetry. If we bring a imaginary line connecting the same kind of groups, right? So in the center of molecule, there is a imaginary point. Okay, this point is called inversion center or center of symmetry, I. Okay, so as this molecule has center of symmetry, so this molecule doesn't show any kind of optical activity, right? So, so other, let's talk about other molecule. Other molecule does have any kind of element of symmetry. This one, B. Hello,
No, sir.
it
It has a
doesn't has, right? It is
but
optic.
environment CH3 and on the other side deuterium replaced by hydrogen by deuterium.
Sorry.
It has a major group with hydrogen on one side, while on the other side it has a deuterium.
Deuterium, yes, the priority will be different. Okay, so
Oh,
here the deuterium, it will get the priority over the CH3 as deuterium atomic number is more than the hydrogen. Okay, so all the other three compounds are optically active. So only compound C is optically inactive compound. Okay, can we move to the next question?
yes, sir.
Okay,
Yes, sir.
okay. So here what is saying, on Pluto, where everything is frozen, astronauts discovered two forms of 1,2-dibromoethane, gauge and anti, assuming that there are no rotations around single bond at the freezing condition. Which statement about these two isomers is correct? So which one is correct?
Diastereomers.
Okay, they are diastereomers. So you know what is the gauge and anti form?
Yes, sir.
Okay, so let's draw. Okay, I am drawing. Which form is this?
Gosh.
Gauge. Why it is called gauge? What is the criteria of calling it gauge? Dihedral angle should be how much? This angle should be what? What is the angle between gauge?
60 degree,
60 degree, or it is m gauge.
Or minus 60 degree.
120 degree.
Not 120 degree. Just think once.
Means minus 60 degree.
Minus 60 degree. How much it is? That this one, na?
Hmm.
And what is this angle? The total circle angle is how much? Total this angle?
360.
360 degree. Minus 60 degree equals to
270. Oh
300.
no, 300. Yeah.
300 degree. If the dihedral angle is 60 degree or 300 degree, then it is called gauge form. And what is this one? How much angle? What is the angle between these
Anti.
two groups? Anti
180 degree.
180 degree. So these two forms are what? Enantiomer,
Diastereomer.
diastereomer. Okay. Any doubt? Any confusion?
Sir, any compound which have a dihedral angle in the range 0 and in between 0 and 180, they must be called gauche right now. Or
Uh,
specifically only 60 degrees corresponds to gauche form.
Only 60 degree. So as you know that this is the staggered form. Okay. And there is some eclipse form I told you earlier, right? Here I discussed that it is eclipse form and this is staggered form, right? So when in these two groups with respect to this one, these two are the gauge position and this one is the anti position. Okay.
Okay, sir.
Okay. So can we go to the next question?
Yes.
Okay. So let's tell me what is the priority order of these groups. You know how to determine the priority.
Yes, triple bond should be broken with more further bond.
Yes.
So there we can get the parity.
Yes, we have to replicate the bonds first, right?
Hmm.
Okay. So sorry. So let's discuss the first two group. Okay, the COOH group and COH whole 3 group. Okay. So here,
CO2H, there is COO.
yes, COOH and the another group is COH whole 3, right? So this
Yes.
bond we can break in this way. Here is oxygen. Here, as it is, OH group will be there, and here we will do the and here it is as it is. Okay, so this process is called replication, right? So breaking the double bonds into single bonds, and these atoms are called the phantom atoms, right? You know the concept of phantom atoms.
Yes.
Yes. Okay, when then these are the we have to make up the valency of the other molecules, and other than hydrogen, we consider all the atom of valency 4. So here we have managed the valency as you can see, right? So now tell me which one is the most of a higher priority, that COOH group or COOH whole 3 group?
COOH.
CO2H.
CO2H. How? Because here carbon is fixed. So this carbon is also connected to the 3 oxygen. Here also 3 oxygen is there. But here oxygen is connected to the hydrogen,
Well,
right?
hydrogen.
But here
But
oxygen is
oh,
connected to carbon.
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 Yes. So that is of the higher priority, right?
Yes.
So the same way we can break the acetylene bond. So in this case, which one is of the higher priority?
C triple bond CH.
C triple bond C. And why it is so? Because
Because over there it is connected to carbon, and over here beside carbon there is a H3
yes,
group.
yes, yes. All the carbon atom here are connected to the hydrogen atom, but here the carbon is connected to the two carbon atom, right? So here C triple bond C will get the prioritized over CMe3. Okay,
Yes.
okay. So any confusion, anybody?
No, sir.
Okay. So now coming to the next question, structure of the L-phenylalanine. So you know the nomenclature of L and D. What is D and L nomenclature?
Yes, for L, and the prioritized group should be in the right hand side.
Yes, exactly. So let's discuss how from where this concept come. Okay. So can you tell me structure of the means name of this molecule? This is the shortest sugar molecule, smallest. Okay, I am saying it. This is glyceraldehyde.
Hmm.
Okay. Yes, you are absolutely right. This nomenclature, L and D nomenclature, is used to designate the sugar molecule like carbohydrate or the amino acid molecules. So here we have to put the carbonyl group, right? Either it is CHO or COOH group must be at the top of the molecule in the Fisher projection formula, and the in case of sugar it is OH, and in case of amino acid NH2 group, either it is right side or left side, right?
Yeah. The second one is L. Right side one
Yes,
means which you drew on the right side. That is L.
yes, this is if right side, then it is which conformation? D or
L.
F?
Right side it is L.
No, this is right. If it is right side, then it is D. Okay, dextrorotatory, then it is right side. Okay, and
Hmm.
if it is in the left side, then it is L, levorotatory, left.
Okay.
Okay, so in our case, which one is the right answer? So is this the incorrect form? Whatever we have discussed that.
Now we have to change CO2H,
Yes.
NH2. We have to change that,
So let's
and
discuss
CH2PH.
what is the configuration of the first formula. If we rotate this, okay, upside down, okay, 180-degree rotation, then how does it look? If COOH goes upward, then CH2PH this one, then hydrogen will come this side, and NH2 will come this side, right? So which is it is
Yes.
D or L?
D.
It is D.
This is D.
Yes, it is
D.
D. Yes, NH2 is in the right side, right?
Hmm.
Yes. So you can do it by yourself that B and C. B1 is same configuration as A. This is the
D.
just inverted one. It is D. So if we change this one D, then how does it look? Upper carbon is fixed. We are fixing it, and we can change the in this way. This group we can shift. right? And hydrogen will
Then
come.
it becomes L.
Okay, then it is in the left side and it is L, right? So the right
Yes.
structure of the L phenylalanine is this one, last one, D, right?
Yes, sir.
Okay. Any confusion?
No, sir.
Okay. You have to put the carboxyl group in the upward topmost carbon, and then we will define the D or L either by the OH or by the NH2. In case of carbohydrate, we will go for the OH group, hydroxyl group, and in case of the amino acid structure, we will go to the NH2 group, right?
So
Yes.
anti-clockwise rotation is not possible.
Yes, you are saying this one here, this one.
Yes. Yes.
Yes, anti-clockwise is also possible. We are just trying to put NH2 either is left or right. If we put in the anti-clockwise position, then NH2 will come here. But
D.
hydrogen, the lowest priority group will come in the vertical position. We don't want that. We have to put NH2 or OH and hydrogen in the same, in right or left. CH2OH or the CH2PH group should be in the downward position. Okay, so lowest priority group we have to put in the vertical line, sorry, horizontal line.
Horizontal.
Okay, so as hydrogen is here lowest priority group, we have to keep it in the horizontal plane. So in this way we are getting this structure, this configuration. We can move anyhow, either left or right, that is not an issue, but we have to maintain our required position.
Okay, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Okay, so tell me which one is different from the other three. Tell me which one is different and why. Hello.
Option C.
Why?
Sir, because 1, 2, and 4 are the identical structures.
Okay. And the configuration is different in case of.
Yes, sir. Configuration different for 3.
Okay, so if we check the priority, so in this, which is the first priority,
OH,
OH.
OH.
then second one,
Then pH. pH.
then H,
CH, then
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 CH3.
CH3.
CH3. So if we go like this way, 1, 2, 3, then which configuration is this?
S.
S.
R.
S.
S.
So how does it come R?
It's
No, sir, it
clockwise.
says
It's clockwise, but there is a catch.
horizontal.
The lowest priority group is in the
Oh,
horizontal
Horizontal.
plane.
horizontal.
Okay. So there is
Ah.
a rule, you know, that very good rule it is called. When the lowest priority group is in the vertical plane, okay, like this way. What configuration is this? R. R.
R.
R.
But
R.
if we,
Sir, S.
why yes?
Second.
Why yes?
No. Sorry, sir. Second structure.
Sorry.
So from the
No,
example,
I am
second
not
structure it
talking
says.
about example. This is an arbitrary structure. I am just
Yes, sir. Sorry.
explaining that is. I am. And which structure is
Yes.
this?
This is S.
S.
This is S. Yes. As. So this is there is come the very good rule, that is the if the lowest priority group, that is here 4, is in the vertical plane, right? This is the vertical plane is there. So it will go the follow the same configuration it has, that is it is clockwise, then it is R, right? And here you can see that the lowest priority group is in the horizontal plane. So we have to change the absolute rotation. If it is clockwise, it should be R, but here it changes to S. Okay, clear?
Yes, sir.
Yes, sir.
So if we check the priority of this one, two, three, right? It is R or
R
S?
configuration.
R configuration. So if we check the other two groups, that is the same as S, only the compound 3 has the different absolute configuration, right? R it has.
But in the before problem where there was hydrogen and NH2 ligand, over there hydrogen was the lowest priority. We were keeping it in the horizontal position.
Uh, where?
The previous problem where there was in one ligand there was hydrogen, another ligand there was NH2. We were keeping the configuration of hydrogen always
No, this is completely different.
horizontal.
This is DL nomenclature. Okay. And this
Uh,
is RS nomenclature. The things are completely different. There is no such correlation between DL and RS. Okay, this is the convention, right? The designating a compound of D or L. So whenever we can say it is either D or L when a compound is represented in this manner. The topmost carbon is has the carbonyl group, then OH and lowest priority group OH or NH2, here has to be NH2, is in the same horizontal plane. This is a way of representation, and here we are dealing with the absolute configuration R or S. Okay, here it is
understood.
no problem if we change it accordingly. If the lowest priority group in the horizontal and vertical position, then the priority will get changed accordingly. Okay, so which one is the correct? Have you done this? Tell me which is the correct answer. Anybody? Anybody wants to say anything? Hello.
Sir, 2 or 3s would be the right answer.
Yes, 2R and 3S will be the right answer. So let's discuss how. Let's first change this
Huh?
numeric. Sorry. Okay, so let's
No, no,
first.
no, it's all right. It's all right.
Okay, so let's first convert this Newman to the Fisher. You know how to convert the Newman to the Fisher projection formula. Okay, at first we can change this to the Short's formula. We have to make it in the any rotation you can take. Not necessarily chlorine has to be in this position. You can take also CH3 and iodine. Anything you want to put. The configuration will be same. Okay, so this one is the back carbon, right? Carbon 2, and this is the carbon 3. This carbon is the downward carbon, this one, and the back carbon is the this one, right? Any confusion?
No, sir.
Okay.
Okay. So tell me here which one is of the highest priority for carbon 2?
Bromine.
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 then
Fluorine.
bromine, fluorine,
fluorine, then
carbon 3,
CHO or this one?
CHO.
carbon 3.
Sorry, which carbon?
Third
This one?
carbon.
Sir, the
The
third
downward
carbon,
travel carbon.
The third carbon, yes. This one will get the third priority. Why not CHO? Here carbon is attached to the oxygen, but here this
oxygen,
carbon is oxygen to the chlorine and
iodine.
iodine, right?
Two
So
groups.
obviously this carbon will get prioritized over the CHO carbon. Okay, clear?
Yes, sir.
Yes, sir.
Okay, so which configuration is this?
R.
R.
R,
As the lowest priority group is in the vertical form.
vertical
Vertical.
position.
Vertical form, yes. And in case of this carbon, which one is of the highest priority?
Iodine,
Iodine,
then chlorine,
Chlorine.
then carbon 2.
then carbon 2. And which is this?
S
R or S?
configuration.
S
S.
configuration. Why so? As the CH3 lowest priority
Horizontal.
group is in the
Horizontal.
horizontal plane, absolutely. So in this way, is this clear to everybody how to assign R or S configuration to a stereo center?
Yes, sir.
Whatever I have discussed, that very good rule. When the lowest priority group is in the vertical plane, then it will go the same notation it is getting, and when it is in the horizontal plane, then we have to change the notation. If it is clockwise, then it is S. If it is anti-clockwise, then it is R, in case of that lowest priority group is in the horizontal form. Okay.
Okay, sir.
Okay, so let's move to the next question. So tell me, what is the right answer? Anybody? Which is the 2s, 3 small s and 4r? Okay, let's first tell me what is the meaning of the small s. And follow that here s
Pseudochirality.
is, sorry,
Pseudochirality.
yes, pseudo chirality or pseudo asymmetric center,
Pseudo asymmetric center. Yes, sir.
right? Pseudo. And what is the definition of pseudo asymmetric center?
It must have a center of symmetry, but for groups must be the different.
Yes, not center of symmetry always. It must have the when the molecule or an atom having containing a element of symmetry, right? A plane of symmetry or center of symmetry. Then such, uh, then the absolute configuration of that group is defined as the pseudo asymmetric center. So from this definition, we can eliminate two options. Can you tell me how?
Plane of symmetry, you say?
Yes, any element of symmetry the molecule should have.
Option C, D, we can eliminate.
Yes, option C, D we can eliminate from seeing the option. Why? Because this C and D doesn't
There
have
is no,
any
yes,
plane of
plane of
symmetry,
symmetry.
right? So if
Yes,
the
sir.
3 is small s, that is pseudo asymmetric center, then it must have a element of symmetry. So we can, by seeing the option, we can eliminate the these two options. Okay, so let's
Yes, sir.
start taking our discussion. Which one is the correct option? That is 2s. So if we start from the compound one, if we start with this center,
Option
then which
A.
one is of the highest priority?
I did.
Iodine.
Iodine. Then
Iodine,
Second
carbon
carbon.
3,
Downward
then
carbon.
methyl,
second carbon, and third
Mhm.
methyl.
methyl,
Topmost carbon.
topmost carbon. And which configuration is this?
S.
S.
It's R. No?
Why R? The lowest priority group is in the horizontal plane,
Horizontal.
na?
Yes, sir.
So if though it is clockwise rotation, but you will note it as the S. Okay.
Oh, okay, sir.
Okay. So can we assign this carbon now?
No, sir.
No, sir.
Yes, we have to assign this carbon first, right? Which is this
R configuration.
R configuration. And if we now consider this one, then this one is
Iodine
the
first
first priority,
priority.
iodine.
Yes.
Then which one? This one
R.
or this one?
Sir, R because R precedes term.
Yes,
Yes.
R precedes S and Z precedes
E.
E. Always when there is a R or S, there is a we have to choose the priority. Then R prioritize S. So here 1, 2, and 3.
R is greater than S.
Yes. So here it is small s, right?
Yes, sir.
Is that clear to everybody?
Yes, sir.
Yes, sir.
Okay. And there is a sigma plane as you can follow. Okay, so the upper part is the mirror image of the lower one. So a center of symmetry passes to the middle of the molecule. So this molecule is called the pseudo-asymmetric center. Though this molecule having the center of plane of the symmetry, so it is defined as the small s, right?
Yes, sir.
Any confusion? Anything?
No, sir.
Okay. Now tell me, chirotopic and stereogenic. We have to consider this carbon center, right? So what is the formula of stereogenicity? What is the condition if we can call a center stereogenic?
So if we interchange two groups, then we get a new stereoisomer.
Hmm. So so which one is the right option? Hello? Hello? Is this center stereogenic?
No, sir.
No, sir.
Why not?
It has on the other side it has hydrogen.
Yes, the two groups are the hydrogen. If we change the position of the two groups, that is two hydrogen, it will not create any new stereoisomer. So stereogenicity is not. It is
Non-stereogenic.
non-stereogenic. And whatever chirotopic or achirotopic, what about chirotopicity? What is the definition of chirotopicity? Anybody?
The carbon must be dissymmetric, no?
Yes, the side symmetry of this atom should be chiral, right? Thus, if the molecule has any kind of element of symmetry, like center of symmetry or plane of symmetry, then that molecule is achirotopic. But in this case, does this atom has such element of symmetry?
No, sir.
No, because if we think about a sigma plane, then it is not dividing the whole molecule in two equal halves, right? So
Yes,
it is chirotopic or achirotopic, this center?
chirotopic.
Pyrotic. Any confusion, anybody?
No, sir. Okay.
So tell me which one is the correct option. True about the R2-bromopentane. Tell me which one is the, in the absence of specific data, which of the following statement is definitely true? Means other than any kind of data, which one is the absolutely true?
So the molecule would be optically active.
Yes. So can we say it whether it is dextrorotatory or levorotatory? Can we see from the seeing only the R2-bromopentane? Can we predict whether it is dextro or levo, D or L? Is there any correlation between RS nomenclature or DL nomenclature? Can we? No, there is, we cannot draw any kind of correlation between the DL and RS nomenclature. Okay. So just by seeing that whether it is R or S, we cannot say whether it is D or L. Okay.
Sir, why not?
Because you cannot draw any kind of correlation. Na? The nomenclature system is completely different. As we can see, that is, we can say it D or L, as I showed you earlier, when the form is represented in a particular form. That is, C double H group is in the higher, in the topmost carbon, then OH or NH2. Just by saying OH or NH2 is in the right or left, we are saying it in the L or D. So there is no such correlation between RS and the DL nomenclature. So only we can say that it is optically active. No other in absence of no other information, we cannot conclude regarding other two things, whether it is D or L. It is optically inactive. No, it is not optically inactive. Right? It is optically active compound.
Okay, sir.
It cannot be optically inactive. Arbomopentane is what? So one is hydrogen, bromine, CH3, and this large group. So can you see any kind of mirror plane or center of symmetry passing through the molecule? Can we draw any kind of element of symmetry here?
No.
No. So if in absence of the any kind of element of symmetry, this molecule has to be optically active or inactive?
Active.
Active.
Optically active. So only we can conclude that this compound is optically active. Okay.
Okay, sir.
So now the last one. What is the, wow, how can we see the relationship is what? Homomer, enantiomer, diastereomer, or none of this? Tell me.
Diastereomer.
Diastereomer. How?
You can convert the Newman to Fisher and the Sohars to Fisher.
Yes, yes. We can convert the Newman to Fisher and Schwarz to Fisher. So let's first convert the Newman to Fisher. Okay. So which one is this, erythro or trio?
Erythro.
Erythro. So which one is this one? This one is Newman or Schwarz? The first one, this one,
Newman.
Newman, and this is erythro.
Erythro.
Yes, sir.
And this one is which one?
This is a triophone.
This is the triophone. So what is the correct option? In here,
Dash
two
stereophores.
hydrogens are in the same side, and here hydrogen is in the right side and this one hydrogen in the left side. So which is the right answer option?
Option C.
Option C. That is they are diastereomer. Okay.
Okay, sir.
So any confusion or anything you have any doubt in understanding from today's class? Anything you want to make clear? Any question? Anybody? Any confusion or anything you want to discuss? Anything?
Sir, as a beginner, can you suggest a book for stereochemistry which I can read and understand?
Stereochemistry, you can follow the book Nasipuri. You have Nasipuri. Nasipuri is a very good book. Means in simple language it is written, and you can understand the language of this book. Okay.
Okay, sir.
So are you getting the solutions of discussion of the class? Is that clear to you or not?
Yes, sir. Thank you.
Yes, sir.
Okay, as this is an interactive session, so you can tell me if you need any kind of clarification or modification you want to bring in the class. I am trying to explain the answer which might help you in understanding the problems. So you can also suggest any changes, anything you want to include. Right, so no doubt from today's class?
No, sir.
No, sir.
Nothing, no? Okay. So can we conclude for today's?
Yes, sir.
Yes, sir.
Yes, sir. Thank you.
Okay, then goodbye. Meet you in the next week. Thank you for
Thank you,
joining.
sir.
Thank you. Thank you.
Thank you, sir.